Hello everyone, welcome to the Grind 75 series of my channel. Today we'll be solving the first question of Grind 75, that is the two sum, which is also the first question of Lead Code 2. So the question is, we are given an array of integer nums and an integer target. Return indices of the two numbers such that they add up to the target. We may assume that each input have exactly only one solution and you may not use the same element twice. You can return the answer in any order, is what the requirements have been given. So we have an array and we must check if the target is achievable or not. If it is achievable, we must return the indices. So thinking of the brute force solution, we can traverse through the array two times. One is a two-pointer approach where our I is going to be here and j is going to be I plus 1. So we're going to search till our targets become 9. And once it becomes 9, we can return the two values, but it's gonna take us the time complexity of like n square O of n square because we're running a nested loop. So in order to come out of that and optimize the solution to O of n, we'll be using the hash map. Hash map is a data structure that is used to store key value pairs. So how does it help us? Yeah. So looking at this uh, array 2, 7, and 11, 15. So at first we're gonna store 2 and its index as 0. And now when we go to the next one, we're gonna have something like 7 as the value. So for this 7 as a value, we're gonna do target minus our current number, and we're gonna search if the number of this difference, that is 2, present in the hash map or no. And if it is present, we're gonna return the index of the current number and the index of the hash map, the hash map's value. Yeah. And if it is not there, we'll just be pushing the value like 7 and 1. We'll be pushing it, and if nothing is returning, we'll be returning an empty array. This is gonna be our approach. We'll be starting the by taking the length of the array. Now we'll be creating a hash map in C++, which is done by un on third and third map, because we'll be mapping the key pair values, integer and integer, the data types, and the name, variable name, and we'll be starting the loop like uh, in I is equal to 0, I plus than n, I plus plus. Yeah. So basically, we're gonna come to 1. Now that 1 is obviously not present in anything, so we'll just push it inside. So first we should find the complementary number, integer complement complement. That is, complement is nothing but target minus the current value is equal to target minus nums of I. And now we must check if it is present in the hash map or no. So it's gonna be like if hash map dot find, that is our complement. This, this is how we check in C++, check if an element is present or no. So if we have it, we should return two things. One is the current index and the index of the complement, right? And if it is not there, or if it is there, either ways, we'll be adding the Then we'll be returning as we'll not have anything. We'll be returning here. So this is the optimized version of O of n complexity because it doesn't take much. Just the for loop of O of n takes us the complexity. And the space complexity here is again O of n because we're creating a hash map of n elements in the worst case. Yeah, so yeah, this is the first question.